So hey everyone, in my last video we have solved this particular question which is from electrochemistry, and I have asked you to solve this particular question based on the same way, like you can just apply the same thing whatever we have solved over here. So let's try to solve this particular question also. Here we need to find out the standard potential of this particular, I mean they have given the standard potential of these two. We need to find out the E naught for this particular reaction. So whenever, if they ask these types of questions, it's better to write whatever they have given in the question first. So here it will be they have given Cu2 plus by capturing two electrons, it is getting converted to, by it is getting reduced to copper. Okay, and here they have given E naught as 0.34 volts. Okay, and in the next reaction they have one C plus is by gaining one electron, it's getting converted to copper, and its E naught is, E naught value is 0.522 volt. One of the like simple mistake, silly mistake you can say, or one of the common mistake you people will do, definitely I'm sure. I'll tell you where you can do. I have already explained you in the last like while discussing this particular question. Okay, so here we need to find for E naught for this reaction. By capturing one electron, it is getting converted to Cu plus. Okay, fine. So we need to find out E naught for this. So how to get this particular equation? Can we do something about it? Like from these two equations, can I get this equation? Just think about it. See here, Cu2 plus is there on the left side. Here also it's there on left side. It's perfectly fine. But here we need Cu plus on the right side. But here it is there on the left side only. So what you can think about it? Like you can just reverse this equation. Just reverse it. So what is happening? Like now copper is getting oxidized, copper plus electron. Okay, now the electrode potential, what happens to electrode potential? It just change the sign, it will become 0.522 volts bus. So now we can play around these two equations. This one just marked as 1, and this one 2. So now what you can do in order to get this particular equation, just add 1 plus 2. Okay, equation 1 and equation 2, if you add it, here you'll get Cu2 plus, okay, and copper. Yeah, let me write it over here. Why to make you confused again? Two electrons, here it is copper, and one more is copper is getting converts to Cu plus electron, and you know these two are getting cancelled each other anyway, and here you will get Cu2 plus, and here we have two electrons, here we have one electron will get cancelled, and one electron will be there on the this side, left side, and here we have Cu plus. We have got the desired equation, right? So that's what, like what we can do it right now. So what you people do over here, this is where people do the mistake. So here, as we added these two equations, we have got the desired equation. People in order to calculate E naught cell, they will directly uh, I mean E naught cell of this particular reaction, let's take it as 1 and 2, not this one, this one. They'll directly add this. Okay, but this is wrong. Like we can't add these electrode potentials. We need to think about Gibbs free energy, because as it is a extensive property, we can, this Gibbs free energy is having additive property, like we can add this, basically delta G1 plus delta G2. From this we need to find electrode potential of this equation. Okay, so here, so now you know, like a minus NF E naught 1, and this will be minus only anyway. Yeah, let it be minus NF E naught 2. Okay, and here this will be minus NF E naught cell. This is the E naught cell that we need to find out over here. So basically how you will do it, so anyway this F will get cancelled out, and N just don't cancel out N. We have, like, that's why we need to go for Gibbs energy, because we need to take care of electrons also, like how many electrons being exchanged. In this case, how many electrons being exchanged? What is N value? N value is 1, right? Yeah, N value is 1, so 1 into E naught cell. And in this particular equation, how many electrons? Here N is equals to 2. two electrons being exchanged. So here minus 2, even is how much? 0.34, 0.34, and it will be minus, what is the n value for this reaction? It is 1. So minus 1 into E naught, like it is minus 0.522. Okay, so now you can simply find out E naught cell. E naught cell is equals to, just take this negative sign over here, or else let me write it one more step. This is 2 4 are 8, 2 3 are 6, and it will be minus 0.68. This will be 0.522. Okay, and E naught cell, like E naught cell will be 0.68 minus 0.522. How much you will get? 0.680. I'm very bad at calculation, you can do it this much, right? Like 10 minus 2 is 8, and here 7 will be remaining, and here it will be 5, and 6 minus 5, yeah, we have got this much answer, which is 0.158 volts. So this is the our correct answer. If you simply add these two, you will get in a negative electrode potential, which is basically, which leads to the cell won't even work. So yeah, this is not the correct way. So just take care of that. You need to take care of the number of electrons being exchanged. Okay, so that's why we will use this particular route to calculate the E naught cell overall. I hope you have understood. I have already solved this particular question same way. If you haven't watched that particular video, you just try it by your own, based on like same methodology you need to follow, bus, that's it. And we'll solve even more questions like this. I have already created videos on like previous year questions of JEE mains, NEET, and JEE advanced. You can check those videos. And also, I hope these videos are helping you out in your preparation. And yeah, do let me know that these videos are helping you out or not. It gives me some sort of motivation to do even, to create even more. Okay, so that's it for this particular video. And one more thing I want to say, I have created one series, which is reagent series. You can just check that out, because you know the importance of reagents, right? Just take a screenshot of this and just try it on your own, based on the same methodology. You just need to follow the same steps. Okay, whatever I have done, you just need to follow the same steps in order to get the answer for this particular question. So I hope you understood all these things, and we will solve few more questions are there still left. So we'll solve all these questions. Okay, and yeah, that's it for this particular video. Just take care of yourself, and yeah, take care, bye.